Hello everyone. If you're watching this, you missed day 2 of our week 12 lecture. Let's go ahead and get to it. So this is the time where we are finishing up our photo liker assignment 040401. It's due Friday the 20th at midnight. We spent a good chunk of class working through it. So if you missed it, you do need to work through that on your own. Please send me an email if something is confusing or doesn't make sense. I'd be happy to go over it with you. But let's go ahead and talk about the other parts that we covered today. We talked about comments and we started talking about conditionals. By the end of today, you should be able to implement programming patterns to develop functioning apps using variables, write comments clearly to explain both the purpose and functions of different segments of code, use debugging skills, and last but not least, appropriate vocabulary to describe Boolean expressions and conditional statements. To start with, we had this little warm-up. This is to harken back to what we've talked about previously about variable scope. If you're going to have a variable, let's say in this case called counter, it needs to be defined outside of your onEvent here. It needs to have some kind of initial value, and it needs to have a definition, so let's say var counter up here. You should not be doing this. This will result in an error. Why? Well, this is saying to create a brand new variable every time I click the button called counter, so there will be no continuity or saving the information. Farther, it has no initial value, so if you try to do counter plus 1, this will give you an error since there was nothing inside counter to begin with. You can't add 1 to something that's not a number, so this will give you an error. This down here will also give you an error for a similar reason. Temp has no initial value. So if you try to add 1 to it, can't do that. However, we did declare it out here, so at least we did something right. You just needed to give it some initial number to hold, like 0. Remember, for the purpose of our class right now, you should be declaring your variables at the top, creating global ones, not inside your onEvents, which would create local variables that can only be manipulated or changed inside the onEvent itself. For right now, we don't have a use for that. Later on in the class, we might, and we will talk about that later. But for now, let's go ahead and move on to understanding comments. Now, for assignments 040401 and moving forward, I'm expecting you to place a comment about every single function. An onEvent is a type of function. We'll talk about more kinds of functions later, but for now, suffice to say, every onEvent should have the following things explained to me, the viewer, above it. In terms of comments, there should be a precondition, what is expected to be true prior to the function being called. That is, maybe you have some number that exists, or it has a value of some kind already, maybe it's positive. It should all be documented there. And the post condition, what should be the expected result of executing that piece of code? What is the expected outcome? If the function is really complicated, give me a quick summarization of what is going on inside, so I don't have to guess. Let's look at an example. So here we have a clicker button. We click it, it does something over here. The precondition is the variable clicker is initialized and its value is positive. So it shouldn't be negative, it shouldn't not exist. It should be somewhere up here declared as var clicker equals something, maybe 0 to start with. Post condition, the variable clicker is incremented by 1. So after we do this, clicker should contain 1 more. Now, if you've never even seen this syntax before, clicker plus plus, you could figure out what this does based on the comments. Same thing should be true for your code. I should be able to figure out what it does based on the comments. This line here increments the variable by 1. It's the same thing as writing clicker equals clicker plus 1. It's exactly the same. Here's a rubric for assignment 040401. Please make sure you read that rubric carefully before you finish it up. There are 2 segments to it. One is to be done on MyMCPS, and the second is to be done on code.org. Make sure you complete both to get full credit. Now, we started on conditionals. Conditionals are a really interesting branch of programming because they allow your computer to make decisions. This makes your program much more exciting Think of your favorite video game. It'd be really boring if everything was predetermined. The randomness, or the ability of your computer to think for itself, is what makes it exciting. We're going to learn how to do that. So far, we've talked about numbers, which we placed on yellow sticky notes. We talked about words, which we placed on salmon-colored sticky notes for the purposes of kind of understanding how they work. Well, now we're looking at a third kind of variable, or value, which is going to be a Boolean. This value can either be true or false. In many ways, it's the simplest kind of value you can have, a yes or a no, a 0 or a 1. This is a binary kind of variable or value. So how does it work? Well, you can evaluate an inequality to figure out whether it's true or not. So is 3 less than 8? Yes, it is. This evaluates to true. You can do similar things to expressions or numbers using other comparison operators, such as less than or equal to, greater than or equal to. If you want to check for equality, you need to use two equal signs. Why? Well, a single equal sign, if you recall, means assignment. So if you use that one, you'll literally be trying to say 3 equals 8, take 8 and put it inside 3. You can't do that. That's crazy talk. So make sure you use two equal signs if you're trying to compare 3 and 8. In which case, 3 equals E would give you false, since 3 is not equal to 8. And last but not least, you can do not equals to by using the exclamation mark to mean not, and then equals to. You can also do simple arithmetic on either side of your comparator. So, for instance, just like in real math, in this example, you would want to add 3 and 6 first, and then compare them to 8. You wouldn't want to compare these first and then add 3. That makes no sense. So 3 plus 6 is 9. Is 9 less than 8? No, it is not. You would get a false. You can try these on your own. Nothing crazy is happening here. You've done these probably in elementary school. You're just computing each side and then checking to see if it is going to work out or not based on your comparator symbol. You can also use variables in similar ways. Remember, if you reference a variable in such a way, it's the same thing as sticking its value in there. So lives is 5, 5 plus 4, well, that's just going to be 9. 10 minus 1 is also 9. Is 9 less than 9? No, it's not. It's equal. So therefore, you would get a false. Now, why is this useful? The reason that's useful is we can make decisions using these kinds of questions. So maybe your question would be, can I go to the movies? I'm allowed if it's before 8 o'clock. If our variable is time, and currently time is 9, well, if 9 is less than 8, well, it's not. So that means we cannot go to the movies. Bummer. Similarly, we can do some math on this side if we need to. Maybe we have a game and we multiply score and lives together, and if it's more than 10, we win. Could do the same thing. Now, an interesting thing happens if we have more than one condition. In this case, we could set up two logic gates in order to figure out if we get to one answer or the other. So, for instance, if we need to have at least $40 and be 14 years or older to get a cat, well, let's say we're 17 years old and we have $39. Plug in 17 into age. Well, that works out. So we can go ahead and move on to our second logic gate here. Is 39 equal to 40? No, it's not. So we cannot get a cat. Oftentimes, we don't want to write a whole bunch of these conditionals one after the other. We want to combine them together. We have a system of doing that. It's called logic operators, and next week we're going to look at some more interesting ones and combine them in more complicated ways. But for right now, the basics are you have two ampersands to symbolize and. You have two straight lines, which you can get by hitting Shift and hitting the button above the Enter key, the backslash button. And these mean or the exclamation point, which means not. How do these work? Well, you take two statements and you can append them together with an or you can take one statement and use a not on it to get a different outcome. For instance, if you get a true statement and a false statement together, the total result is false. So how does this work? Let's take a look at all the possibilities. Think of the example we just looked at. Are we at least 14 and do we have $40? If we do, both are true, that means we can get a cat. so it's true. In the case that we do have enough age, we're 17, but not enough money, we cannot get a cat. And vice versa, if we are not old enough but have enough money, we still can't get a cat. The one that confuses people sometimes is the case where you neither have enough money nor are old enough. Two falses with an and between them make a false. You do not magically get a true out of that. You definitely can't get a cat if you're neither old enough nor have enough money. Both must be true for this to be true. For an or, it works in a similar way. In this case, only one conditional needs to be true for you to get a true out of it. You can think of this as, can we go to the zoo? Well, maybe we can if it's either a Saturday or it's a snow day. Okay, so let's see. Is it a Saturday? Yes, it is. And it's also a snow day. It's snowing outside. Well, we can go to the zoo for sure. It is a Saturday, but it's not a snow day. Doesn't matter, there's still no school. We can go to the zoo. It's not Saturday, but it's a snow day. Oh, great, we have the day off. We can go to the zoo. It's not a Saturday, it's not snowing outside, then we cannot go to the zoo. So as long as at least one is true, this whole thing values to true. Very nice. Last but not least, you have the not. The not operator is very useful. It simply flips your Boolean to whatever the opposite of it is. Trues becomes false, false becomes true. That's it. Hopefully you guys are good with that. Next week, we're going to pick up where we left off and talk a little bit more in depth about various kinds of logic operators and how we can use them, and also something called De Morgan's Law, which allows us to have some interesting ways to simplify really complicated logical operators. Alrighty, thank you guys for coming, and I'll see you all next week.